Welcome to our channel Quaint Cosmos. Today's topic of discussion is so interesting. Have you ever wondered how actually sound travels through a solid world? Or I was talking about sound, how heat flows through a solid object. You know heat can flow through a solid object. You know sound can travel through a solid wall or solid object. Those things are known to you, but how this becomes possible? So that is the topic of discussion here. And behind all these things, the thing which is responsible are called phonons. Yes, phonons. Phonons are what? Phonons are not like electrons or protons. That means phonons are not actually physical particles. Phonons are actually quasiparticles. So in case of quasiparticles, you know that there is no object actually. Physical entity that does not exist. Okay, they are not physical particles. So what are phonons actually? So these are actually collective vibrations of atoms. Only vibrations, not the particles, not the atoms. Okay, phonons are collective vibrations of atoms. If you think about a lattice structure, okay, say in the lattice structure there are billions or trillions of atoms are there, and say, just for example, you imagine like this, okay, all those atoms are connected by springs. So if you move only one atom, what will happen? That thing is known to you. All other atoms, whatever be the number, billions or trillions, whatever be the number, all the atoms will start moving together. That means they will start vibrating together. If only one atom moves, so these collective vibrations of all the atoms are together known as phonons. And these phonons are responsible for heat flowing through a solid rod or solid object. These phonons are responsible for sound traveling through a solid world. Sound travels through air, that is known to you, means gas medium. Rarefaction and means compression and expansion of the waves occur in case of air medium or gas medium. In case of air or gas medium, that is known to you. But in case of solid, how this becomes possible? So, reason behind this is existence of phonons. Okay, so these are what? These are collective vibrations of the atoms, and so this is known as quasiparticle. Quasiparticle. Okay. Again, scientists are trying to manipulate these things to improve devices like semiconductors, thermoelectric generators. Means if you are able to manipulate these things, then those things can be improved. Okay, so scientists are trying to do that thing. Again, if you study superconductor, then you know that superconductor means what? It is an electrical conductor for which the electrical resistance becomes zero. Okay, so that is superconductor. In case of superconductor, what is the requirement? Requirement is formation of Cooper pairs, and formation of Cooper pairs take place only due to the presence of these phonons, these quasiparticles. There was a discontinuity in my during my video recording due to load shedding. Anyway, this is the remaining part of the video. So I was talking about superconductors, and for superconductors, formation of Cooper pairs are required. Okay, and those formation of Cooper pairs becomes possible only due to the presence of phonons, those atomic vibrations, those quasiparticles. Okay, but one more thing is required in case of superconductors, that is special condition is required and special material is required. For all types of materials, superconductivity, this phenomenon cannot be observed. And extremely low temperatures, this is one more requirement. Extremely low temperatures. to reduce the thermal energy of the system so that quantum effects become dominant in that case. Okay, because when the temperature of the system is reduced near to absolute zero, in that case thermal energy of the system is reduced actually, and in that case quantum effects become dominant, and in that case the property superconductivity is observed. But phonons are required because phonons are responsible for the formation of Cooper pairs. Otherwise Cooper pairs wouldn't form, and we cannot observe the property. In that case we won't be able to observe the property superconductivity. Anyway, but for the propagation of sound through solid medium, solid substance, or for heat propagation, okay, flowing of heat through a solid object, for that thing a special condition is not required, like extremely low temperatures or special materials. For all the materials same thing happen. Okay, yes, conductivity of different materials are different, and scientists are trying to manipulate phonons to make conductors of thermal energy. Means, actually they are trying to make perfect insulators. They are trying to make perfect insulators. That means they are trying to make materials which won't allow actually heat energy to flow through them. Okay, in that way they will be able to make perfect insulators. Okay, anyway, so what is the result, what is the conclusion of this discussion is that these phonons, these are actually acting as an, means it works as an intersection of classical physics as well as classical physics and quantum physics. Classical physics, which part? Propagation of sound through solid, then flow of heat through solid. Those are classical part, classical physics part, and quantum mechanics part is what? Superconductivity. Okay. So we can say that phonons are playing a crucial role in the intersection of classical physics as well and quantum physics. Okay. So this was all about today's video. Okay, and okay, so this is the end of this video. Thank you for watching this video.